Let's look at what is referred to as grouped distribution. Here, as an example, I have the height of 100 models. I didn't list, well, these are in centimeter. So let me put this in centimeters. Good. I did not type out all 100 figures, right? But you get the idea. I'm going to do a tally. And here, for example, in doing this tally, I might see 150. 150, cross out 150, and between 153, cross out 153, and that falls between 150 and 154. You see that? What's happening here is that we have a whole ton load of figures, and it doesn't make sense having all of these numbers scattered all over the place. You can't really look at them and see any pattern. Is there a certain range of figures that apply to most? Are most of these persons taller than average, shorter than average? What's happening? You can't really tell. No. You wouldn't want to create a pie chart or a bar graph using 100 different numbers. Can't do that. It doesn't make sense. Alright? With a pie chart having 100 sectors or a bar graph having 100 bar, that wouldn't be very useful. So what you do is place these values in groups. You don't make too many groups, because, example, it wouldn't make sense to have 100 numbers and say you're going to make 50 groups. It's still too much, and you don't really see the pattern in the distribution. Having a bar chart with 50 lines, no. At the same time, you don't want to use too few groups. Example, two groups, 150 to 160, 160 to 180, and that's it. No, it doesn't make sense. Alright? I'm using 1, 2, 3, 4, 5. And I got this example from the Certificate Mathematics book. And they recommend about 5. If you have 100 values, and you use about 5 groups. So, continuing, 162. Let me cross out 162. 162 lies between 160 and 164. So I have a mark here, 168. I see 168, so I cross it out and remember to note it. 168 lies within this group. So it goes here. 154 is from 150 to 154, so it belongs in this group. So let me cross 154 because I've seen it, and I put my mark, my tally mark. 151, yes, 151, still here. I see 151 and it belongs in this group. 168, I'm looking at 168, 168 belongs in this group. 162, let me cross 162, 162 belongs in this group. 153, and so on and so forth. You get the idea. Alright? So you tally these values. Now, I'm not going to spend a long time going through all of them. That's why I did not list all 100 figures, right? But from that example, when it's all done, you will have 8, this group, the frequency. Remember, all right, let me center all of these. Frequency means how frequent, how many. The 155 to 159 group, there are 16 of them. For the 160 to 164 group, I have 43. For the 165 to 169 group, there are 29. And for the 170 to 174 group, there are 4. So, from that example, if I had listed all 100 measurements and tallied everything, these are the numbers that I would have got, alright? But you get the idea how it works. And when you add up all these numbers, they should go back to 100. Alright, so you should add them up and see if they match the 100. So that's group distribution. You place numbers in various groups. You try to make the group equally wide. That 150 to 154, 155 to 159, 160 to 164. Don't have 150 to 154, then 159 to 163. Right? Have each group equally wide from one number to the other. Alright? Now, we're going to return to this at a later time in another video, and we'll talk about a few things regarding these values, these numbers. Example, the class interval, the class boundary, the width of the class interval. We're going to be looking at those later on, but for now, hope you understand the idea that I was bringing forward. Anything, just make me know in the comments. I'll see you in the next video.